Introduction.
1, 2, 3, 4, 5, 6, 7, 8, 9. 1 followed by 9 zeros. Wow! Hey Dhruv, did you know that there are 100 crore bytes in 1 gigabyte? Of course I did. And did you know that if you added 3 more zeros, you get 1 terabyte? I didn't, Dhruv. That would make it a very large number. How do you read such a large number? We say 1 terabyte is equal to 10 to the power 12 bytes. That's really short and sweet too. Is this a new concept in mathematics, Dhruv? Yes, Varisha. It is known as exponents.
In this lesson, you will learn about exponents and powers. Objectives. At the end of this lesson, you will be able to express a number in exponential form, identify the base and exponent of a number expressed in exponential form, compare numbers expressed in exponential form, multiply and divide numbers with the same base but different exponents, multiply and divide numbers with the same exponent but different bases, raise an exponential number to a power, raise a number to the power 0. Exponential form. You heard Dhruv tell Varsha that 1 terabyte is equal to 1 0 0 0 0 0 0 0 0 0 0 0 0 bytes. When expressed so, the number on the right is difficult to identify and use. Hence, such large numbers are expressed in exponential form to reduce their size and make comprehension easy. 1 0 0 0 0 0 0 0 0 0 0 0 0 is nothing but 10 multiplied 12 times. We use this knowledge and express 1 0 0 0 0 0 0 0 0 0 0 0 0 in exponential form as 10 raised to the power 12. Therefore, as rightly pointed out by Dhruv, 1 terabyte may be expressed as equivalent to 10 raised to the power 12 bytes. 10 raised to the power 12 is made up of two integers, 10 and 12. 10 is known as the base, and 12 is called the exponent. We can express large numbers in exponential form by varying the base and the exponent. Look at this number expressed in exponential form. Base is 4 and exponent is 2. It is read as 4 raised to the power 2. 4 raised to the power 2 is nothing but 4 into 4. Hence, it is also read as 4 squared. Look at one more exponential number. Base is 4 and exponent is 3. It is read as 4 raised to the power 3. 4 raised to the power 3 is nothing but 4 into 4 into 4. Therefore, it is also read as 4 cubed. Conversions and comparisons. Integers, decimals, and fractions can be expressed in exponential form. Similarly, exponential numbers can be expanded back to their original form. Exponential numbers can also be compared in much the same way as integers, fractions, and decimals are compared. Let us take a look at conversions and comparisons of exponential numbers one by one. Conversions. Let us begin by expressing 64 in exponential form. 64 can be written as 2 into 2 into 2 into 2 into 2 into 2. Since 2 is multiplied with itself 6 times, it can be written as 2 raised to the power 6. Therefore, 64 is equal to 2 raised to the power 6. Let us now expand 37,456 and express it in exponential form. 37,456 can be expanded as 30,000 plus 7,000 plus 400 plus 50 plus 6, which is the same as 3 into 10,000 plus 7 into 1,000 plus 4 into 100 plus 5 into 10 plus 6, which can also be written as 3 into 10 raised to the power 4 plus 7 into 10 raised to the power 3 plus 4 into 10 raised to the power 2 plus 5 into 10 plus 6. Let us try and express 196 in exponential form. Let us first express it as a product of its prime factors. 196 is equal to 14 into 14, which is the same as 2 into 7 into 2 into 7. We can rewrite it as 2 into 2 into 7 into 7. We can now express the prime factors in exponential form. Therefore, 196 is equal to 2 square into 7 square. Let us now convert some exponential numbers into their original form through simplification. Let us try to simplify. Minus 4 raised to the power 3. Minus 4 raised to the power 3 may be expanded as minus 4 into minus 4 into minus 4, which is equal to minus 64. Simplification of a negative number raised to an odd power gives a negative product. Let us now simplify. Minus 6 raised to the power 4. Minus 6 raised to the power 4 is equal to minus 6 into minus 6 into minus 6 into minus 6, which is equal to 1296. Simplification of a negative number raised to an even power gives a positive product. Let us simplify one more exponential expression, 2 raised to the power 3 into 4 raised to the power 4. First, expand 2 raised to the power 3 as 2 into 2 into 2. Then expand 4 raised to the power 4 as 4 into 4 into 4 into 4. Now multiply to get the product 2048. Let us now evolve a generalized expression for representing numbers in exponential form. If p is a non-zero number, then p into p into p into p is equal to p raised to the power 4. If r and t are non-zero numbers, then r into r into r into t is equal to r raised to the power 3 into t raised to the power 2, which is equal to r cube t square. Comparisons. Let us now compare numbers expressed in exponential form. Let us begin by comparing 4 raised to the power 5 and 5 raised to the power 4. 4 raised to the power 5 is equal to 4 into 4 into 4 into 4 into 4, which is equal to 1024. 5 raised to the power 4 is equal to 5 into 5 into 5 into 5, which equals 625. 1024 is greater than 625. Therefore, 4 raised to the power 5 is greater than 5 raised to the power 4. Let us now compare minus 4 raised to the power 5 and minus 5 raised to the power 4. Minus 4 raised to the power 5 is equal to minus 4 into minus 4 into minus 4 into minus 4 into minus 4, that is equal to minus 1024. Minus 5 raised to the power 4 is equal to minus 5 into minus 5 into minus 5 into minus 5. That is equal to minus 625. Minus 1024 is smaller than minus 625. Therefore, minus 4 raised to the power 5 is smaller than minus 5 raised to the power 4. Let us perform one more comparison between 2.5 raised to the power 3 into 10 raised to the power 3 and 3.5 raised to the power 2 into 10 square. 2.5 raised to the power 3 into 10 raised to the power 3 is equal to 2.5 into 2.5 into 2.5 into 10 into 10 into 10, which is equal to 2.5 into 10 into 2.5 into 10 into 2.5 into 10. We can rewrite it as 25 into 25 into 25, which is nothing but 15,625. 3.5 square into 10 square is equal to 3.5 into 3.5 into 10 into 10, which is equal to 3.5 into 10 into 3.5 into 10. We can rewrite it as 35 into 35, which is 1225. 15,625 is greater than 1225. Therefore, 2.5 raised to the power 3 into 10 raised to the power 3 is greater than 3.5 raised to the power 2 into 10 raised to the power. Assessment. Drag and drop the options in the appropriate boxes. Self-assessment. Select the appropriate symbol to place between each pair of numbers. Laws of exponents. Having understood exponents, let us turn our attention to the laws of exponents pertaining to multiplication, division of numbers with same base but different exponents, multiplication, division of numbers with different bases but same exponent, raising of exponential numbers to powers, raising of numbers to the power 0, multiplication, division of numbers with same base but different exponents. If q is a non-zero number, then q raised to the power m into q raised to the power n is equal to q raised to the power m plus n. Product of two exponential numbers with the same base but different exponents is an exponential number whose power is the sum of the powers of the multiplied numbers. Let us understand the law with the help of some examples. Express the product in exponential form. 9 square into 9 raised to the power 3 is equal to 9 into 9 into 9 into 9 into 9, which equals 9 raised to the power 5 equals 9 raised to the power 2 plus 3. 5 raised to the power 4 into 5 raised to the power 6 is equal to 5 into 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 5, which equals 5 raised to the power 10, which is equal to 5 raised to the power 4 plus 6. If q is a non-zero number, then q raised to the power m divided by q raised to the power n is equal to q raised to the power m minus n. Quotient of division operation between two exponential numbers with the same base but different exponents is an exponential number whose power is the difference between the powers of the dividend and the divisor. Let us put the law to use. Express the quotient in exponential form. 8 raised to the power 6 divided by 8 raised to the power 4 is equal to 8 into 8 into 8 into 8 into 8 into 8 upon 8 into 8 into 8 into 8, which equals 8 raised to the power 2 equals 8 raised to the power 6 minus 4. 12 raised to the power 3 divided by 12 raised to the power 4 into 12 raised to the power 5 is equal to 12 raised to the power 3 into 12 raised to the power 5 upon 12 raised to the power 4 equals 12 raised to the power 3 plus 5 upon 12 raised to the power 4 equals 12 raised to the power 3 plus 5 minus 4, which equals 12 raised to the power 4. Multiplication, division of numbers with same exponent but different bases. If p and q are two non-zero number, then p raised to the power m into q raised to the power m, which is equal to p into p into p till m times into q into q into q till m times, which equals p into q into p into q till m times, which is equal to pq raised to the power m. Product of two exponential numbers with the same exponent but different bases is an exponential number whose base is the product of the bases of the two numbers multiplied and the power is the same as theirs. Let us understand this law with the help of some examples. Express the product in exponential form. 7 raised to the power 5 into 8 raised to the power 5 is equal to 7 into 7 into 7 into 7 into 7 into 8 into 8 into 8 into 8 into 8 equals 7 into 8 into 7 into 8 into 7 into 8 into 7 into 8 into 7 into 8, which is equal to 7 into 8 raised to the power 5, which equals 56 raised to the power 5. If p and q are non-zero numbers, then p raised to the power m divided by q raised to the power m is equal to p upon q raised to the power m. Quotient of a division operation between two exponential numbers with the same exponent but different bases is a fraction with the base of the dividend as the numerator and the base of the divisor as the denominator raised to a power same as theirs. Let us now use the law. Express the quotient in exponential form. 9 raised to the power 6 divided by 4 raised to the power 6 is equal to 9 raised to the power 6 upon 4 raised to the power 6, which is 9 upon 4 whole raised to the power 6. Similarly, 36 raised to the power 5 divided by 12 raised to the power 5 into 4 raised to the power 5 is equal to 36 raised to the power 5 upon 12 raised to the power 5 into 4 raised to the power 5, which is equal to 36 upon 12 whole raised to the power 5 into 4 raised to the power 5, which equals 3 raised to the power 5 into 4 raised to the power 5, which is equal to 3 into 4 whole raised to the power 5, which will be 12 raised to the power 5. Raising of exponential numbers to powers. If p is a number, then p raised to the power x whole raised to the power y is equal to p raised to the power x into p raised to the power x into p raised to the power x into so on till y times, which is equal to p raised to the power x plus x plus x plus so on till y times, which equals p raised to the power xy. If an exponential number is raised to a power, the result is the base raised to the product of the two exponents as power. Let us look at some examples. 7 raised to the power 7 raised to the power 3 is equal to 7 raised to the power 7 into 7 raised to the power 7 into 7 raised to the power 7, which is 7 raised to the power 21, which equals 7 raised to the power 7 into 3. Similarly, 24 raised to the power 3 raised to the power 5 is equal to 24 raised to the power 3 into 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 24 raised to the power 3, which equals 24 raised to the power 3 plus 3 plus 3 plus 3 plus 3, which is 24 raised to the power 15, which is equal to 24 raised to the power 3 into 5. Raising of a number to power 0. A number raised to the power 0 is 1. If s is a number, then s raised to the power 0 is equal to 1. Let us solve some questions based on exponent 0. Simplify 8 raised to the power 3 divided 4 square into 2 raised to the power 5. We get 8 cube upon 4 square into 2 raised to the power 5 is equal to 8 into 8 into 8 whole upon 4 square into 2 raised to the power 5. Now by further simplifying it, we get the answer 1. Standard form. What is common among these numbers? 9.8 into 10 raised to the power 3, 7.3 into 10 raised to the power 4, 5.82 into 10 raised to the power 5, 4.73 into 10 raised to the power 2. All of them contain decimal numbers between 1 and 10 multiplied by powers of 10. Numbers that are expressed as products of decimal numbers between 1 and 10 and powers of 10 are said to be in standard form. Express 9347 in standard form. 9347 is equal to 9347 upon 10 cube into 10 cube, which is equal to 9347 upon 1000 into 10 cube, which equals 9.347 into 10 cube. Now express 345 in standard form. By simplifying it, we get 345 upon 10 square into 10 square, which is equal to 345 upon 100 into 10 square, which equals 3.45 into 10 square. Self-assessment. Match the numeric expressions on the left with the exponential forms on the right. Summary. Let us summarize what we have learned. Expressing a number in exponential form, identifying the base and exponent of a number expressed in exponential form, comparing numbers expressed in exponential form, multiplying and dividing numbers with the same base but different exponents, multiplying and dividing numbers with the same exponent but different bases, raising an exponential number to a power,